Welcome to the series on chaos destruction. In this video, we'll be covering how to embed static meshes into our geometry collection. Embedding is used to add visual elements to our fractures, such as internal rebar supports to a roadway structure, without adding additional physics processing to our geometry collection. If you're not familiar with the tools in the fracture mode window, then I would suggest you check out part 1 in this video series. A link to the project files bundle offer, and other relevant Epic links are in the description below. So let's get started. So what's so special about embedded geometry? The short answer is it's more performant than adding more geometry to your geometry collection's original static mesh. Adding more geometry to your source static mesh puts more work on the physics solver when you run your simulation. But when you use the embedded tools to add geometry, i.e. static meshes, to your fractured geometry collection, those embedded static meshes are ignored by the physics solver while still providing additional visual elements to your fractured pieces. So you get the look you want without all the extra simulation overhead. Let's run through the tools using a simple example. In this scene, I have one box panel geometry collection that I've fractured into 4 bones. Along the bottom, I have 3 colorful static mesh spheres that we'll use to embed in our geometry collection. In the left panel, let's scroll down to the Embed section. You'll see we only have 3 tools in this section. Embed and Auto do the embedding work, and Flush removes all embedded meshes from your geometry collection. Let's start with Auto, since this is the one you'll probably be using most of the time. Auto is great for bulk operations because it allows you to embed a bunch of static meshes into your geometry collection at one time. And Unreal Engine handles parenting them to the nearest bone for you so that they follow along for the ride during the simulation. Let's try it out with our sphere meshes. The spheres don't have to intersect with your geometry collection in order to embed them. Now that our spheres are placed where we want them, select all the spheres along with our geometry collection and click on Auto. If you look in our fracture hierarchy window, you'll see Unreal assigned our static meshes as child bones to our geometry collection. It does this by finding the centroid of each static mesh, which is the geometric center, not the pivot location. And it assigns it as a child element to the nearest bone in our geometry collection. So Auto Embed is great if you have a lot of static meshes that you want to embed and you don't care what bone they get parented to. The other thing that happened is that an instance of the mesh was created and assigned to the geometry collection. If I explode this out, you'll see the original static meshes are still in place. The Embed tool will also instance your static meshes. This is done to help reduce the simulation overhead. It's important to remember to delete your source meshes from your scene, or at least move them out of your geometry collection before you run the simulation. Otherwise, your simulation may not run correctly. The other thing to note about embedded meshes is they have no collision assigned to them. This means other fractured pieces will pass right through them and not interact directly with the meshes themselves during the simulation. Let's move our source static meshes back into their original location and out of our geometry collection before we run the simulation. Okay, let's run the simulation now. As you can see, the embedded meshes followed their parented bone during the simulation, even when they were placed outside the geometry collection. Let's reset our geometry collection before we check out the Embed tool. You have 2 ways you can remove embedded meshes from your geometry collection. If you only want to remove selected embedded meshes, just select them from the viewport or your fracture hierarchy window. Then in the Edit section, click on the Prune tool to delete them. If you want to remove all embedded meshes from your geometry collection, make sure your geometry collection is selected. And back in the Embed section, click on Flush. If you deleted your source meshes instead of moving them out of the way like I did earlier, you can get them back by enabling Extract as Static Mesh Actors, and they will be returned to your outliner. Finally, click on Flush Embedded Geometry to remove all embedded static meshes from your geometry collection. Next, let's try out the Embed tool. Think of the Embed tool as manually embedding your static meshes. You decide which bone you want your static mesh parented to, not Unreal Engine. The Embed tool allows for more precise placement of your static meshes. And like the Auto tool, your static meshes don't have to intersect with your geometry collection if you don't need them to. I'm going to enable Show Bone Colors by hitting Shift+B. This will help me to precisely place my static meshes. Let's start by placing the green sphere at the very bottom tip of the top fracture in our panel. Let me explode out our geometry collection slightly to help us out with that. Well, it looks like we got a problem. As soon as I selected our green sphere, our geometry collection became unselected. When that happened, Unreal reverted to rendering the root proxy of the geometry collection. In other words, it reverted the geometry collection back to its resting state. We have two ways to fix this. One is to open the geometry collection and set the custom renderer type to none. This effectively tells Unreal Engine to use per bone rendering instead of the root proxy. But for me, the easier way is to just issue a CVAR to basically do the same thing. So in our console command window, enter the following CVAR: p.Chaos.GC.UseCustomRenderer 0. This CVAR is a true or false value. So by setting it to 0, which means false, we're telling Unreal Engine to disable the custom renderer altogether. Now when I select our green sphere, our exploded bones stay in place. Let's continue with our embedded task. Once our green sphere is in place, we want to also select the bone we want to parent it to by holding down the Control key and selecting our bone. It will change to a hatch pattern once selected. Now click on Embed. Like the Auto tool, it created an instance of our static mesh, but this time it parented it to the bone we selected. Before we do anything else, let's re-enable our custom renderer by rerunning our CVAR, but this time changing our 0 to 1 to signify true. We could get some weird results if we tried to run the simulation otherwise. So get into the habit of re-enabling your custom renderer as soon as you're done with your editing process. Next, let's move our source green static mesh sphere back to its original position. Now let's run the simulation. As you can see, our embedded green sphere follows our selected bone perfectly. One thing to keep in mind, once you embed a static mesh, you cannot readjust its position. You have to delete it via the prune tool, then reposition and re-embed it again. Let's do a quick review of when to use each tool. If you have many static meshes that you need to embed into your geometry collection, and you don't care which bone they get parented to, then use the Auto tool. If you need precise control over your placement of your static mesh, and/or you need to parent it to a specific bone, then use the Embed tool. This concludes this tutorial on how to embed geometry. If you found this tutorial helpful, please hit that like button and subscribe to the channel. Also, if you want to support this channel, click on the Buy Me a Coffee link in the description below. I'll see you in the next video.